Hello and welcome to 5-5, day number 2. We are continuing our discovery of these new formulas for trig. Today we're going to start with the power reducing formulas. And it says the double angle formulas can be used to obtain these power reduction formulas. Notice on the left we have squared stuff. Sine squared, cos squared, tan squared. We can replace those with the things on the right. And notice the things on the right are not squared or cubed or anything else. They're all first power. And notice also they only have coses in them. So the sine squared of u becomes 1 minus cos of the double angle over 2. When this angle jumps in, no matter what it is, you multiply by 2. You double it. Same thing for cos squared of angle u. When you use this formula to reduce the squared down, the angle is going to be multiplied by 2. And since tangent is sine divided by cos, if we bring this one up and flip it and cancel the 2's, we have the sine's numerator and the cos's denominator, or the sine's numerator as this denominator, 1 minus cos over 1 plus cos. Each of those, again, are double angles when this angle jumps into the formula. Okay, new formulas, just like a new car. Got to take them for a test drive. And here they start us off pretty powerful one. It says rewrite sine to the fourth in terms of first powers of cosines of multiple angles. So we're starting with sine to the fourth. We only want coses to the first power. It doesn't matter what the angle is, but as long as they're coses to the first power. So first, we're going to rewrite sine to the fourth as sine squared of x quantity squared. Because if we square a square, we would multiply those exponents. That is the same thing as sine to the fourth. And let me see if I can, yeah, there we go. All right. So we've got sine squared. Let me stick with the red. I'm going to put a set of big red brackets here. And I'm going to put the square outside still. That's this squared is coming down to the next stage of the problem. But in the brackets, sine squared, we have a formula for that now. Sine squared, 1 minus cos of the double over 2. So this becomes 1 minus cos of the double angle, 2x, divided by 2. Okay, and I wrote that kind of huge, but I can do this. Now, the numerator, we are going to FOIL that out. That's going to be 1 minus the cos of 2x quantity squared. Notice if we square this denominator, that's going to be 2 squared or 4. Now, usually what you'll see in a textbook when they're doing something like this, since that denominator is just a number, we're going to sort of drag it out in front of the parenthesis. And since 4 was a denominator, when we drag it out, it stays a denominator. So we're going to bring it out. Now it is a 1/4 minus the cos of angle 2x, that quantity squared. Okay, again, so that 4 just got dragged out. Make sure it stays a 4. It was a denominator. It should stay a denominator. And this will just make it easier to maybe work and FOIL this out. So 1/4 times the quantity. If we FOIL, first times first is 1. This is a minus, so our next term will be a minus. This times 2 is going to be cos of 2x times 2, or 2 cos of 2x. Now, last times last, minus times minus is positive. Cos 2x times cos 2. No, that squared is in the wrong. There we go. That was throwing me. Cos of 2x times cos of 2x is cos squared of 2x. Now, I wrote that in red because it's another power we have to reduce. We started at 4th power. We got it down to squared. Now, we're going to use the formula one more time to get the red stuff that's squared down to first powers of cos. So, I've got my 1/4 bracket 1 minus 2 cos 2x plus, now I'm back to red ink, we are going to replace cos squared of 2x with the formula 1 plus cos of the double angle. Now remember, the first time we used it, x jumped in here and became 2x. Now we're using the formula again. This 2x is going to jump into the next formula and double to a 4x. And that's over 2. Now, that's a good answer. But usually you're not going to see fractions left within here like this. Now this might be the part, if you're going to make a mistake, it's going to be here. This is a 2 and this is a 1. If we factor a half out of the red brackets and bring it out here, we've also got to factor a half out of the 2 and we've got to factor a half out of the 1. Now what might make this less confusing, let's rewrite those numbers as halves. 1 is 2 halves, minus 2 is 4 halves. Cos 2x plus 1 plus cos 4x over 2. Now it might be a little easier to see when we factor a half out of every term. So it's kind of like we're going to collect up all these denominators. This 2 is going to get dragged over with this 2, is going to get dragged over, and they're all going to come out and become a 1/2, and we've already got a 1/4 out there, so that half times a fourth is going to become 1/8. 1/8. And now since we've dragged out all these denominators, we just have the 2 minus 4 coses of 2x. Plus, now since this denominator got pulled out, just that numerator stuff falls down. 1 plus the cos of 4x. All right, in those brackets, I guess there's just a couple things we can combine there. Now be careful. The cos 2x is an apple, the cos of 4x is an orange. You cannot combine them. These are different angles. So we cannot do that. But we've got a 1/8. And let's put the number first. Well, let's do the cos of 4x first. Cos of 4x goes first. Minus 4 coses of 2x. 4 cos 2x. And we got a 2 and a 1. Last I checked, that's 3. Now again, let's reread the directions. Rewrite sine to the fourth in terms of first power of coses of multiple angle. This is cos to the first. This is cos to the first. It's okay that our angles are multiples of x. That's fine. We have done what the directions asked. Now I see some type down here in the corner. What's this? Using a graphing utility to check the result as shown below, notice the graphs coincide. So we could take a T89 and graph sine to the fourth, and somebody else at your table could grab a T89 and graph this answer that we just found, and the graphs would be absolutely identical. They are the same graphs. Okay, so we saw the power reduction formulas. Now here are half angle formulas. These can be used to sort of fill in some of the gaps we have on the unit circle. We have our friendly angles, like in the first quadrant, 30, 45, 60, and 90. But some angles that aren't on the unit circle, we can find using this. These angle U's should be our friendly angles on the unit circle. Like maybe this U is 120 or 135. The U angles are going to be on the unit circle. Okay. Now notice too, I'm going to start at the bottom here, the signs of these depend on the quadrant in which it lies. So you see these pluses and minuses, that depends on which quadrant our angle is going to fall in. And if we look up here, sine of the half angle is either positive or negative. We got radical 1 minus cos of u over 2. So whatever this angle u is going to hop in, and then this cos of u, we should be able to find that on the unit circle. But that original angle divided by 2 is not on the unit circle. For cos, the only difference is change this minus to a plus. So the cos of u over 2 is the root of 1 plus cos of u divided by 2. Tangent is sine divided by cos. Now here they give us a couple of options. This first one, our denominator is a single term, 1 minus cos over sine. An alternate form of that is sine over 1 plus cos. Here our denominator is 2 terms. And what's this remark? To find the exact value of a trig function with an angle measuring degrees, minutes, and seconds using a half angle formula, first convert to decimals, blah, blah, blah. Okay, here we go. And again, this is how these formulas are useful. The sine of 105 degrees, that's not on the unit circle. It's not one of our friendly angles. But we can find the exact value. You know, if you punch that into a calculator, it's still just a rounded decimal. But if we put it in a formula like this, the sine, we could rewrite 105 as 210 over 2. 105 is not on the unit circle. 210 is on the unit circle. That's one of our friendly angles. So we can use this formula. Ooh, now first let's get this out of the way. We're at 105 degrees. 105 degrees, 90 would take us to here. So 105 takes us into quadrant number 2. All students. So sine is going to be positive. So right now, before I forget, I'm going to put a plus sign there because we've already determined that this value is going to be positive. Now for sine, what goes under the radical? 1 minus cos over 2. 1 minus cos over 2. So again, we could not evaluate 105 on the unit circle, but when this jumps in and becomes 210, you know, this 210 is what jumps into our formula. So that's 1 minus the cos of 210 over 2. Now that's just working on the unit circle. I'm going to bring down my plus. Here's my radical. We've got 1 minus, and then downstairs is a 2. We go to our unit circle. The cosine at 210 is a negative root 3 over 2. Okay, let's clean this up and make sure we have good math manners. Radical sign. This minus a minus, that is going to change to a plus. So that is 1 plus the root of 3 over 2. And that's all over 2. And we've determined it is positive. Okay, I see a fraction under a radical that's also has a fraction under it. Fractions within fractions are bad manners. Whoa, get back there. So we are going to, underneath the radical, multiply the numerator by a 2. And of course, we're going to be fair and do the same to the denominator. So in the numerator, distribute the 2 to the 1, so that becomes a 2 plus. If we distribute here, that'll be 2 root 3 over 2, and the 2's cancel, so just leaving a root 3. Now look, is that the first time you've seen a radical under a radical? Okay, downstairs, 2 times 2 is 4. Now, because it is a fraction, we can separate the numerator and denominator. I'm going to put a separate radical over the 2 plus root 3. And then downstairs, the square root of 4 is just a 2. So there is the exact value of the sine of 105 degrees. Calculator not required, just some formulas. All right. And I see a remark down in the corner. Whoa. It says use your calculator to verify the result obtained in the example. That is, evaluate the sine at 105 degrees, and that also on your computer, and you'll see that the decimals do match up. Okay. I think it's practice time. Tan to the fourth. So use the power reduction formulas. You're going to use it twice. Once to get the tan to the fourth down to a tan squared, and then you're going to have to take the tan squared and reduce it again. The second one there, exact value of cos 105. You're just going to do the very something similar to a different formula from the half angle formulas. So pause the video and try the problems. Okay. tan to the fourth we could write as tan squared squared. So I'm going to make those into brackets, and we got our squared outside. And if we go to our formula sheet, there's only one option for tan squared, I believe, or was there two? Oh, not half angles. We got to go back to the other ones. There we go. Oh, no, back. There. 1 minus cos of the double over 1 plus cos of the double. So this is going to be 1 minus cos of 2x over 1 plus the cos of 2x. So each of those, numerator and denominator, we are going to square them. I'm going to put a division line right here. And I'll do red, blue for the numerator. So this, if we FOIL it out, first times first is 1, minus, middle term are these two multiplied, and then times 2. So that's going to be 2 coses of 2x. And then last times last will be a plus cos squared of 2x. So there we're going to have to use a reduction formula on that cos squared. And then the denominator, I'm going to switch to red. If we FOIL, will be 1 plus 2 coses of 2x plus a cos squared of 2x. Okay. And move this up here. And I don't want to forget that we got to do next. So I'm going to go back to black ink. In that numerator, I should switch back to blue for that. 1 minus 2 cos 2x plus, I'm going to sort of block this off in a set of black brackets, because now that's going to get replaced with the formula again. So we're going to use the 1 plus the cos over 2. And remember, when this angle jumps in, it doubles again. So when this 2x jumps into the next use of the formula, that 2x doubles to a 4x. Okay, down in red, we've got 1 plus 2 cos 2x plus, this is going to get the exact same treatment. We're replacing a cos squared just like we did in the numerator. So that is a 1 plus cos of 4x all over 2. Now at this point, because tan is a little different than the formula we did in the example, we could, just like the example, factor a half out of the numerator and factor a half out of the denominator, and then they'd be out here and we could cancel them. But it might be safer, since if you notice the numerator has its own divide by 2, we could just block off this numerator and distribute a 2. And we could do the same thing down here. I'll use green ink, block off the denominator, and distribute a 2 there also. So that would be a different way to get to the same answer. It might be a little less confusing. So let's distribute this 2. So that's going to become a 2 minus, 2 is going to hit here and become a 4 cos of 2x. Plus, now remember when we distribute here, it's just going to wipe out this denominator. So we just bring down the numerator 1 plus cos 4x. Now to the denominator, distribute the 2. 2 plus 4 cos 2x, and then we distribute here, so that's just a plus 1 plus cos 4x. And now we just combine some terms. In the numerator and denominator, we can just combine the constants. 2 and 1 is 3 minus 4 cos 2x plus a cos of 4x all over 2 plus 1 is still 3 plus 4 cos 2x plus a cos of 4x. Okay, good answer. Looks kind of messy, but it is technically correct, and we fulfilled the directions. Again, what they asked us to do, rewrite tan to the fourth in terms of first powers of cos of multiple angles. All right. That was the big one, the tricky one. This one shouldn't be too bad. Exact value of the cos of 105 degrees. Again, 105 degrees is not one of our friendly angles that is on the unit circle, but that's not going to stop us. So now, just like in the example, 105 degrees, we are in quadrant number 2. All students, cos is going to be negative. So cos is negative in this quadrant. So the cos of 105 is not on the unit circle, but 105 is 210 over 2. 210 is on the unit circle. And that is going to make the jump into our formula. We got our big old radical. We've determined our answer will be negative. Let's put that negative sign on there right now. And that is 1 plus cos of the angle over 2. So the 210 jumps into the formula, and we can find the cos of 210 on the unit circle. Big old radical, minus sign outside. Underneath that radical, we have a 1 plus, and in the numerator, the cos of 210 is a negative root 3 over 2, and that is all over in our formula 2. So, good manners tell us we don't want fractions within fractions. So, I'm going to switch to red ink here. We will distribute a 2 across the numerator. So that's going to be negative radical. And here's my division line. 2 goes to the leading 1. 2 times 1 is 2. The plus and negative will just be a minus. And then we'll distribute here. That'll be a 2 root 3 over 2, and the 2's will cancel. So 2 minus a root of 3. Don't forget to also distribute a 2 in the denominator. 2 times 2 is 4. One last thing to make it look extra pretty. We are going to do radicals separately around the numerator and around the denominator. So negative, let's get the denominator out of the way first. Root of 4 is 2. Upstairs, we've got a big old radical with 2 minus a root of 3. Notice the root of 3, that radical is under the other radical. Radicals within radicals. Absolutely beautiful. There's our exact value of the cos at 105. All right, our last example, I believe, for this video. Yes, it is. Find all the solutions of this mess, 1 plus cos squared equals 2 cos squared of half x, on one trip around the unit circle. So we're not looking for infinitely many answers. Okay, where to begin? I'm just going to copy the problem down here. 1 plus cos squared x equals, now here we've got a cos squared, so it might be a power reduction formula, but I also see the x over 2, so it might be a half angle formula. So I'm going to try to write it like this. We've got 2, and then here is our cos squared. Cos squared. So I'm going to find the cos squared half angle formula and put it in here. So the half angle formulas are all radicals, and they all have a plus or minus on them. Now, this is a quantity squared. If it's plus and we square it, it's positive. If it's negative and we square it, it's positive. So this is just going to be positive no matter what. And then what's underneath there is 1 plus cos x over 2. 1 plus, that's supposed to be an s. 1 plus cos x over 2. Okay. So the left nothing's going to happen over here for a little while. 1 plus cos squared x equals, well, let's see. Here, the square and the square root will cancel. So the radical is now gone. So we're left with 2 over 1 times 1 plus cos x over 2. So again, square and square root have canceled. And now if you look again on the right side here, we're going to have the 2's on the diagonal cancel. 2, 2. So what are we left with? 1 plus cos squared on the left side equals 1 plus cos x on the right side. All right, we are getting close. What are we going to do now? Let's get everything on one side, set it equal to 0. And I'm going to choose the left side because over here cos squared is positive. So cos squared, we'll keep it over here. It's going to stay positive. We are going to minus cos from both sides. So now it's a minus cos over here. And then if we subtract 1 from each side, they just cancel. So now that's equal to 0. Ooh, and I like where this is going. This will be easy to factor and set our factors to 0. So there is no constant, so we're not going to have to sort of unfoil this. We're just going to factor out a cos. Pull a cos of x out, and what are you going to be left with? Cos x minus 1. Okay. So we've got some factors multiplied to 0. Let's set the first one to 0. Cosine of x equals 0. Cos values are x values. When is x 0? That's when you're on the y-axis. And that occurs on the unit circle at a half pi and also 3/2 pi. In the parenthesis, if we set that equal to 0, we're going to get cos of x is equal to positive 1. And that only occurs at 0 radians. X equals 0 radians. We could put the plus 2 pi n stuff on there, but remember we are restricted to 1 trip around the circle. So we do have our 3 solutions, 0, half pi, and 3/2 pi. And I do see it says down here graphical. So what's that look like? Yeah, we could just graph it on there and then find the x-intercepts. At 0, the calculator will tell you approximately 1.571. That's your half pi. 4.712. That is your 3/2 pi. All right. Ooh. And here is a practice problem for you. So cos squared equals, here's sine squared of a half angle. So let's keep the left side as a cos squared. And then over here it's sine squared. So that's going to be sine squared. Go to the formula sheet, get the sine of the half angle, and put it in there. All right, pause the video. See if you get the same solution as I did after you start it back up. All right. The sine of a half angle, that is plus or minus, big old radical, 1 minus cos x over 2. 1 minus the cos of x over 2. And again, that is quantity squared. So the left side we'll leave alone for now. And over here, the square and the radical are going to cancel each other out. So we're just left with 1 minus cos of x over 2. All right. Ooh, and I like where this problem's going. Let's multiply both sides by 2. If we multiply the left side by 2, now it's just 2 cos squareds. And if we multiply this side by 2, the 2's cancel, leaving the 1 minus cos x. Okay. So let's set it equal to 0 and factor. So I'm going to keep the 2 cos squared on the left because it's positive over here. We're going to add a cos to both sides, so now it's plus cos x. And then we're going to subtract 1, so it's a minus 1, and that's equal to 0. And it's factor time. Get up there. Two cos squared must come from 2 cos x times a cos x. The factors of 1 are 1 and 1, and we want the middle to be a plus cos, so that means we're going to multiply here by 2. So we want this to be the positive 2, and then the minus 1 will take us to the plus 1 in the middle. Okay, we're getting close. For this one, to get cos x by itself, we're going to first add 1 and then divide by 2. So cos is a half. Where does that happen? At 1/3 and 5/3 pi. 1/3 and 5/3. The other factor, set that equal to 0. You're going to get cos x is negative 1, and that only occurs at one spot, at pi radians. And there's our solutions to the original equation. All right. The homework is on WebAssign. In the book, it's page 388, these 4 problems. But again, those are on WebAssign. And we're going to do some odd problems in class that will help with those even ones when you're working on them. All right. I will see you in the day 3 video, and we will wrap up these formulas.